this thing happens this way. But if we jump to the coding, it will affect many of us, because when you're explaining that, you will not grab. So I will share some slides which will just go through for us to understand what happens when we are talking about machine learning. How do we instruct computer? What and what do we need to inform the computer to know? So let me share my screen. Okay, let me share the entire window. Yeah. Okay. Guys, you can see my screen.
Yes, yes. I can see your screen.
Okay. So like I said in the group chat, how machine learning works and how the computer learn is the same thing the way human learn. There is nothing different. Because when you have enough information about a particular case study, you have a high chances of making predictions about that case study compared to someone that don't have much knowledge about it. So when you come to computer area, when we deal with machine learning, the amount of data, when you have much number of data that you use to train a computer, the more computer gets to know more. So the same thing also apply. And also in computer, when you bring a new data that it has not seen before, it cannot predict it. That's the same thing happens to human. It's like someone speaking Chinese to you when you don't understand Chinese. You can't decode what the person is saying. So computer also behave in that way. It cannot interpret what it has not seen before. So in learning, when we want to teach computer, there are so many types, but I don't want to, because this thing is just a boot camp. I'll just tell you the major ones you need to know. When we are discussing in the group, for example, when we are talking about Toyota, assuming you have been seeing Toyota, so many brands of Toyota, you can be seeing the cars, you know that this thing is car, this thing is black, but nobody told you that it's Toyota, but you are seeing it. Assuming that the name is not attached, or let me leave something like Toyota, maybe something like chair. You have been seeing chair, different kinds of chair, but nobody told you that this thing is chair. You will understand that, okay, there's this thing people used to see there, but you don't know the name. And another group of person, they're also teaching them when they see the chair, they will tell them this thing is called chair. Two of you are learning. One person is learning based on he's seeing this thing based on the structure, and another person is also seeing the structure and knowing the name. It's two different types of learning. Such type of learning also happens when you are teaching computer. And what we call those learning is where we call what we call supervised learning and unsupervised learning. In supervised learning is that when you are showing computer something, you have to be telling it the name. But in unsupervised, you show without mentioning the name. What the computer will do is that it can learn from what you observe about that particular entity in question. So when we have a label, when we are tagging something, okay, this thing is chair, this one is chair. Such type of learning is supervised. But when you are given a data without tagging a label on it, we refer to such type of learning in machine learning as unsupervised learning. But in this data analysis, where we'll focus on is supervised learning, because any data we are using, we have to label it for computer to know where we are heading to. Is that understood?
No, please, Chinedu, please, can you come again? Can you repeat yourself? I didn't understand the difference clearly.
Okay.
Thank you.
No problem. Let me use something like food, for example. We have so many data on maybe Igbo soup, for example, now. And we have 1,000 pictures of egusi soup, 1,000 pictures of nsala soup, 1,000 pictures of oha soup. You will now give computer this 1,000 of egusi soup and tell computer, this is called egusi. You gave it oha soup and tell computer, this is called oha. You gave it the nsala and also inform the computer that this label for this particular one is oha soup. For the fact that you are defining the label that this one is this, you are giving this is the name for this one is this one is this, defining the label of each of those data. When you are using such data to perform your learning in the machine learning, we call that supervised learning because you are tagging those labels of where those data belongs to. But in a situation whereby you are giving the data without the label, computer can still know the difference, but it does not know the name. What it will do is that that's what we call clustering, that it will put this one, anything concerning this that is looking like oha, it will keep it one side. This one, this side. It can differentiate the three, but it doesn't know the name. In those ones, it's unsupervised because there is no label attached to those your data. But you can still recognize that there is difference between the three. But when you attach a label, so that when it is predicting, it will be telling you that it's oha because you already informed him that anything that looks like this is oha. So that labeling of the data is the difference now. The one we label is what we refer to as supervised learning. But the one we don't label is unsupervised. Is that clear now?
Yes, thank you.
Okay. So please, anyone that don't understand, please, so, okay, Samuel.
Sorry, I was trying to use the thumbs up. I mistakenly clicked on raise. Sorry.
Okay. Thank you. So that's but in this course, our main focus is on supervised learning. Okay, let me go to something like here now. Let's say these are our data now. If our target is that this one is the label, we are looking at people that survive based on all this data we have here. How can we predict the people that survive and someone that did not survive? For the fact that you are giving computer all this sex, age, this one for each of the person and saying this is for survived. Anyone that have anything related to this information here survived. This one did not survive. This one survived. You're already giving a label of someone that survived and the one that don't survive. Assuming that we remove this label and trying to check how can we now know the people that survived based on this information? Computer can still try the prediction. But in most cases, supervised learning is always advised because you specify what you want and computer will learn from that. So let's move on. As we go on, everything will be more clear. Now, the major thing we learn when we say machine learning is we are just learning the pattern, which is the same way human beings learn. That when you see someone's face, that you're able to recognize is because you have already known the pattern of how the person's face look like. That's why if the person snapped 20 pictures, when you see that 20 pictures, you can still recognize, okay, yes, this person is Chukwudi, or this person is Ebuka, because you recognize the pattern on that person's face. So when we are learning in computer also learn with pattern. And that pattern now it will form a sort of, if it is in data analysis, though it's not the term they normally use, but in a normal simple term is, we are looking for a formula that will be generalized to solve every problem. Let's say, for example, now, we have this data, something like this sum, for example. If we give computer this data now to learn from, computer will now check, okay, when 3 plus 2 plus 1 will give you 6. Maybe this one is our label data. This one is our label. We are telling computer that this thing gives 6. This ones give this. This one give this. This one give this. What the computer will be learning is, what is the pattern that goes on here that makes this answer to come out? And when you check, the pattern that is going here now is addition that is going here. Anytime you bring in 3 numbers, maybe now if we, after training a model and we give computer something like 7, 1, and 2, the computer will automatically predict 10 because it has already learned that the pattern of what is happening inside here is all about addition. So that's why when you come here, they will tell us that a function to map features to an output. This one now is the label we want to predict, and these ones are the data we are giving the model to predict from the data. So now the goal of the machine is to predict by learning from data. It will learn from this data to understand the pattern that is going on the data and be able to make a prediction. So that's what the computer do. The major thing is learn, whether it is numbers, whether it's pictures, number is anything is learning over there is to understand the pattern, which is the same thing human beings communicate to make their own prediction. Once you understand the pattern of what is going on, you can be able to predict anything and you predict it right. So that's why this formula is what we just like generally, this is how the machine learning works. This is the output we are looking for. You give it a particular X, this data, it will learn from it to predict any of the output. So to explain the formula very well, we say that the Y is the output. This one is the one making the prediction for us. And these future vectors are the data. These future vectors we are seeing here is the data. Like, for example, X, Y. These ones we want to use now is our X. A, B, and C is the X. And the target we are looking for is the Y. So any function that applies to this data give us this output, which is 6. Once you apply any function here, it will give us 8. This one. But that function will now be the model you are training at the end. Don't bother on how we train the model. I will show you how to call the library that will learn the pattern for you. You are not the one doing it. Once there is a model, an algorithm that you will call from our library, the way we call other library, your duty is to pass your data inside, and it will help you to learn the pattern in that your data. So once you pick your data, put it inside that particular algorithm we are going to call. Once it's learned, and we check that, okay, yes, it's learned very well, that model can be making predictions for us. So like we have here, the F, prediction function, X is future vectors, the attributes. When we talk about attributes is something like messenger, P class, name, sex, age, all these things are attributes. And our Y, if this one is our target, you know that our Y is survive. This is the output we are looking for. And these ones are the attributes. So computer can learn the pattern of what is happening here to determine when someone survived and when someone did not survive. It can learn from this information. So if this one is our Y, every other information here is X, because our Y is determined by function of everything that happens in this place that will determine our Y, which is the survive, depending on the target you are looking for, is your Y. Are we together? Are we together? Or should I explain again? Okay. So that's what happens here. So like here, we said that the program that is used to generate the model is called algorithm. So this one, that algorithm now is what we are going to call from our library. And we pass our data there, and it will give us the predictions. In machine learning, we have different types of tasks, which is what you are meant to know when you receive any data. We have two types of tasks when it comes to machine learning. It can be regression task or classification. When we are talking about regression is if you are working with a continuous data. Continuous data is, let me give an example of continuous data. Let's look at this data now, for example. We want to check the pattern on HIV death rate in Nigeria. This thing is just synthetic data, not real data, it's just synthetic. I was the one that just generated it. So now, if we choose something like this one, we choose as our Y. This is the target we are looking for. And we find out that this target is not looking for they died or they did not die. We are not classifying whether they died or they did not die. What is showing us is the number of people that died, which if 20,000 people die is a function of what happens in all this information we have here. The literacy rate, unemployment rate contributed to 20,000 people to die. The same thing happens when 1,000 is a function of what happens in our X. Now, we are not doing a definite prediction to say, okay, they died or they did not die. It's not classified. It is a continuous data that if this thing changes, the number can even go to 20 million. We are not checking death or not die, or death or alive. That's not what we are checking. If you are checking death or alive, you know that you are classifying to know, okay, this X makes these people to die or make them to be alive. But in a situation whereby the number that will come out as your output is continuous, is not within a particular range, it can go up or it can go down. Such data will refer to it as a continuous data. If your target is continuous data, you know that the type of task you can perform in such data is a regression task. But if you have a defined output is, for example, this our data we have been working with. Our defined output is whether they survive or they did not survive. That is 0 or 1. We are classifying if they survived or if they did not survive. In such task, what we call such task in machine learning is classification, because we want to classify the people that died or people that did not die. But in a situation whereby the output is a continuous number, not something defined within a particular class, you know that that thing is a regression task. It's like when you want to predict weather forecast. It's not defined within this or that. It's a number that is continuous. So all those ones are just a regression task. But when you are doing classification is when you are predicting this or this. This happens, this one did not happen. This person is alive or is dead. This one is black or this one is blue or this one is yellow. That is what we refer to as classification. So anytime you get your data, first thing you have to check before you start designing your model is which one is my target? Which one am I looking at? That is, which one is your Y? That the output is dependent on every other variables. So, and when you have to choose, how we choose is also dependent on what the organization is looking for. Maybe now, if it is a banking data set you are working with, and they want to know why most of their customers are leaving, they want to go, they want to change bank. So what you know now is that it will be a classification task whereby you are checking those people that is still staying with the bank and people that is leaving. You now have to perform to design a model that will be able to check the data of each of the customer to determine why they are staying and why some are leaving. In such situation is classification task. But if it is something that is continuous, you just know that such task is a regression task. And also when you come to your classification, is divided into two, which is binary classification and multi-classification. When you talk about binary classification, you know that the classes you have is two. It's just two classes, which is the way we are having survived or not survived, the way we are having 0 or 1, like the prediction you are looking at is just two classes. But when you have a prediction that is more than two, maybe you want to predict, okay, the way we have 6 geopolitical zones in Nigeria, and you want to design a model that can predict the zone where someone is coming from based on the information provided. You find out that what we are predicting is 6. We have 6 options to choose to predict, okay, this person is from southeast, south-south, southwest. In such type of prediction is multi because we have more than 2 classes we want to predict. Or if it is just 2 classes you are looking at to predict, you know that we call that a binary classification. Any question? Okay. So now, this is what happens when we want to train a model, the machine learning in your data analysis. When we have our data, we perform feature vectors, the algorithm, and the model. We have to explain all these things one after the other for you to understand. The process to generate a model is called training. Like you have to train your model, the algorithm with your data, and now a model will come out, which is what the company or the organization is looking for. Is this thing at the end point? Is this model that everybody is looking for? This model have learned the pattern of the data and can predict any data given to it. So now, let's discuss about these two first. We have training data and test data. These are the types of data we normally use when we want to perform training in machine learning. The first one we have is training data, validation data, and testing data. In this course, we will not be looking at this data. The one we'll be working with is training and testing. But for you to understand the concept when they talk about training data and testing data, let's use this X-train is your training data. What do I mean by X-train? Where is our, let me use this. We have how many data here? 1, 2, 3, 4, 5, 6, 7. We have 7 data here. And the norm of what is always advised is you have to take 80% of your data for the training. So if we should choose 80% of the data here, maybe we choose, let's say from here to here. Let's assume that this one is the 80%. This one in bold form. We are not touching this part. This is the one we want to use to train the computer from this 3 to 4, so that the computer will learn the pattern here. So this one is our X, X train is this one we have chosen. And the next one we have is the testing data. The testing data is this one that is remaining here. What we use this testing data to do is that when we use this one to train the computer and we have a model, we now give it this one to know if our computer can predict the correct answers. We gave it this one to train. After we are done training our model, we use this one to test to know whether what the computer is predicting is correct or not. Why we can check whether it's predicting is correct or not is because we know the answer. So we have to compare the answer that we have with the one the computer is predicting. So that's why I said that the concept of what we normally use to understand is this your X train is like when they are teaching you in the class, which is this first part, this one in bold. Then this one now is your X test. This one is the testing. After training, you use this one to test what the computer have learned. You use this one to test. And when you come here, we have the Y train. The Y is our target, which is answers used to used for explanation in class. That is, when the teacher is teaching with this X, he's telling you that this one is the answer. That is the way you have to inform the computer. This one is the data we are learning from. Oh, this is the answer. This X train is this answers here from 6 to 5. We gave computer this one, the X, for the training, and we provided the output, which is the Y. I think when we are writing the code, you will understand how the, those things work, how we impute it. Computer has to know that, okay, these ones are the egusi soup, oh, and this is the name we call it. So from this pattern now, computer will be able to know, okay, when these 2, 3, and 1 exist, we are having 6. When we have 4, 3, 1, we have 8. When we have this, we have this. This one, we have this. Computer will now learn the pattern of what is happening here and also see the answers that you provided. So what you will now do, since this answer is what we refer to as our Y train. Now we have the one we call Y test. Y test is this answers here, which we are not touching from our test part. 713 should be giving us 10. This one is our Y test, which is after training our computer with this and providing this answer, we have a model that we have trained. After we have provided this thing to the computer and tell computer this thing, and we pass it through the algorithm we are going to call from the library. And the thing we learn over there, after learning, we pass this particular from this side, we pass it inside what the computer have learned. Computer will provide an answer, which we always call, we use a variable Y-pred. That is the prediction that your computer made. That prediction that is made now, you have to compare it with the correct answer because you know the correct answer, but you're not showing it to the computer. Once you are done training with this, you pass this test inside to the computer. Any answer that the computer provides, you compare it with the correct answer. So now comparing it here now is when you will know whether computer is doing the appropriate prediction or not. Assuming that after you are done training here and you pass this data to the computer, expecting it to bring out 7, 9, 10, and it brought out another thing. When you compare with this, you find out that the error in your model will be too much, showing that the computer did not learn anything. What you have to do is that you have to go back here to go and train again until your model starts behaving well. So here, that's why we have Y-train. Y-train is the labels we give when we are teaching. Then the Y-test is the one we use to compare to any prediction our models perform. When we compare the two, that is when we will know if what the computer is giving is correct or not. So we use the training data set to train the computer, and we use the testing data to test if what the computer learned is appropriate or not. You select 80% of your data for the training and use the remaining 20% to test what the computer have learned, whether it learned it well or not. That is how we use our training data and testing data. We are not going to make use of this in our bootcamp, unless if when we are done with this beginners level, if there will be another bootcamp ahead, then we still have a lot to discuss about in the machine learning aspects, because this thing is always confusing most times. So any question so that we'll continue? Do we have any question in the chat? Any question? Especially those that is not in computer science, because it will always be confusing. Feel free to ask your question. Okay. So that's about the training data. Now, the next thing we do when we have gotten our training data is the future vectors. These future vectors let me use this example. Your future vectors is this your A, B, and C. Future vectors are those variables that will determine your output, are your future vectors. So when you select the future vectors that you will use to make your prediction, so that, which implies that A, B, and C is what we are going to pass into the algorithm where the computer will learn from. We pass this thing because combination of this pattern is what will determine our output. So this one are the future vectors we are going to select, which is A, B, and C. The next one we have is the algorithm. So now this algorithm is inside this particular library. We get it from this scikit-learn. So I'll tell you how to import, so that when you import the particular algorithm that you want, you now pass your data inside of that particular algorithm. There are so many of them, and also they have a specific task that you can use each of them to perform. So that algorithm is inside this library. So when you bring the algorithm and call it up, when you call the algorithm, you now pick this your data and pass inside the algorithm for the computer to make the necessary predictions. So after that, after the training, you now have your model. This model is what maybe the organization can integrate it in a mobile app, they can integrate it in their website or anywhere to perform the prediction. Anytime such data has come in, the computer will automatically predict the outcome. So this one is the model you are looking at. After your training, you have a model. So this model now, we take it here and bring that our test data. This test data is for us to confirm if this model is working proper. Like I told you, we choose 80% to train and use these ones to test. So in this second stage, which is this part, you are now bringing the testing data to pass it inside the model and check the predictions the computer will do. So once the computer do the necessary prediction, in fact, you know that your model is working well. Then if what it predicts is not actually what you needed, you know that you have to retrain. And there are so many ways to retrain your algorithm for you to have a good result. So this one is the process that is involved when you want to train your machine. First of all is that the raw data is like when we imported our data during this class. This thing is a raw data, is what we have here. So after the raw data, transformation happens. What happens in this transformation is when we are doing our cleaning, removing the ones that don't have a value or filling an information here, then we can drop the columns that we think that is not necessary in this our task. For example, someone's name don't have any contribution to know whether the person survived or not, because name does not have any effect. So you can remove the name. Something like passenger ID, during the transformation, you remove the whole columns that you think that is not necessary for the predictions that you want to do, for the model you want to train. So that is what we do during the transformation. That is when you are cleaning your data and doing everything you want to do. Now, the next one is the feature selection. This one is when you are now selecting the features and the label. These ones are the features. The feature vectors are those ones that your label, this one is your label, the one you want to predict is your label. And all these ones that will help you to know the pattern that makes someone to survive or alive are your features. All these ones are the features that determines if someone survived or not. So this one now, which is the target, is your label, and all these ones are the features. So you combine these ones to predict the survival rate, whether they survive or not. So once we have the features, the next thing is to split them into training, testing. So like I've explained before, since we already know our features, then we can say, okay, 80% of this data will be used for training, while the remaining 20% will be used for testing. The training data will pass the training data will pass through the algorithm and will have the model. And this model now, we now use the test data to test if our model is working or not, because it will bring out the predictions it made. Any prediction it makes here, we compare it with the true answer and know whether our model is performing well or not. So that's what happens here. Once you have the features and the label, we split. After splitting, then you train your model. You pass it inside the algorithm, and then you now have your model ready to deploy. So this was, I think I've explained this slide. Now, these are the various algorithms that we have. In this one, there are more than this, but I just selected these four. When I mean algorithm, are those where you can pass your data. And this algorithm that we have here is existing inside this library called scikit-learn. This is where we are going to import the algorithm from and then pass our data inside them. Now, each algorithm have the type of task you can use it to perform. For example, if we have a binary classification where we want to determine two classes, we have to go and call this algorithm. You can use this logistic regression algorithm to perform it. We can also use then decision tree, the same with support vector. These ones can perform binary classification also for you. Then when you want regression, when we are looking at continuous data, that we are not doing classifying, we are just checking one output coming out because it's a continuous data, you can make use of this linear regression, or you can also use support vector. All these things are algorithm inside the library. So when you have a task, you have to know the proper algorithm you are going to call. There's one we call decision tree. There are so many of them. When you browse, I think it's up to 10 or more than that. So you have to call the one that you think that is appropriate to the task you want to perform. So not when you have a multi-class. That is when you have more than two classes you want to predict. You will go and be using this logistics. It will not work. It will give you an output, but the answer prediction is giving you will not be accurate. So if you have more than two outputs you want to predict, that means you'll be going for support vector or decision tree. And there are other ones you can also choose. So which implies that, assuming that is decision tree that we want to use, it means that when we have our training data, we select the features. We'll call that decision tree here and pass this data inside. It will learn from that algorithm, and also our model now appear. And this model will now train, we'll bring it down here and bring the data set, our test data, pass inside the model we have trained, and now check the prediction to know whether the model did the right prediction or not. So these are the algorithms you can use. And where you can find this algorithm is inside the scikit-learn library. I'll still teach you guys on how to import those libraries to your, the way we do pandas, that's the same way we call all those algorithms, all those libraries. When you call the particular algorithm you need from the scikit-learn, it will appear. I'll show you the syntax on how to use them on your code. So when you are done with the training of the model, during the testing, there are some metrics you need to use to confirm if your model did the right prediction or not. And those things are what we call the evaluation metrics. For example, you can use the accuracy to determine how your model is predicting. And what the accuracy is doing is checking the correct prediction out of the total prediction. How does it check this? After training our model with this information here, this one is the feature vector, and this one is our Y, which is the answer to the pattern here. We now have a model existing. We now take this data. We are not touching 7, 9, and 10. We are not touching it. We are just taking this data. We'll give it inside our model to make a prediction. Maybe at the end, what the computer will predict, maybe it will predict 7, 9, and 10 as the prediction. Now it will now take this 7, 9, and 10 and go and compare it with the correct answer to know whether your model is doing the proper prediction or not. So now when it now do the comparison is when, if it is accuracy you are checking, if you are checking the accuracy, it will now check how many correct prediction did he do out of the total prediction. For example, assuming that this one, it predicted 2. So you find out that the only thing it got correct is 9 and 10, that this one did not predict it well. So your accuracy will not be 100%. Maybe accuracy might be something like, it will tell you that your accuracy is 80% because it did not get the predictions well. Remember, when we use this information here with the label to train our data, we now have a model. After passing it through the algorithm, this model will exist. You now take this data and pass inside the model you have trained. It will make a prediction. You now take the prediction and compare it with the correct answers. You now determine if your model is training well or not. That's what we now use the accuracy to check. Sorry, seems I'm running too much. Any question? I forgot to come and ask you, sorry. Any question? If you don't understand, maybe I can explain again. Okay. So this one's in the bold is our X train. This one, the answers here is the Y train. And this one is the X test, the one we are using to test the model. And this answers here is our Y test. So you use your X train and the Y train, which is the answers, to train, pass it in your algorithm. Once it enters inside the algorithm, you have trained a model. That model that you train, you take your test data, these ones, which is maybe 20% of the data, the one you left for the testing. You now pass it inside this model. It will make a prediction. Based on this thing now, it will bring out a prediction. You take these two predictions and compare it with the correct prediction to know whether two of them match. If two of them match correctly, you know that your model will be giving 100% accuracy, which implies that when you deploy such model, any data, if you put in such data here, it can predict the answers correctly. So the next one is, so we can use accuracy for regression. You still remember when I talked about regression task is when your target is a continuous data. Then the classification is when you are classifying between some number, you want to choose within some labels, whether true, false, or not. You can use accuracy to check, to evaluate if the model is working well or not. Now, mean square error, you apply that during the regression. What this one is doing is that it's checking the average of square differences between prediction and actual value. That is the average of when it calculates the difference between these two. So what it will do to this is it will find the average and square the differences. So all these ones has some mathematical background, but when we are writing the code, I'll tell you to know the values that when you are using the MSE, the values that when you get something like this, you know that your model is working proper or not. Now, another thing we have here is we have confusion matrix. We use this one for classification. So what this one does is that it will bring out a table. Don't know if I have an example of confusion. Checking if I have a picture. So I'll show you guys how confusion matrix looks like. Let me show you something. Something like this. This one is not too clear. So this is how a confusion matrix looks like. Wait, this thing is not too clear. Sorry about that. But this is how a confusion matrix looks like. It will bring the predicted labels here and the true label. It will now be comparing and be telling you how many times your this thing did the correct predictions. So we use the confusion matrix when we are working on classification task. That's where we make use of confusion matrix. So we use this for classification tasks to check. It will be a form of a table showing how your label was able to predict. It will be visualizing it to you to show you how many number of times it predicted it well and when it did not predict it well. Then we also have recall, actual positive that we are correctly predicted. All these things, I think in the code, we are going to see all of them and how those outputs work. But the major thing I want you to take home today, the concept I want you to understand is this diagram is the major thing that you need, which is when we have our data, this data, the first thing you have to do is you have to divide it into your training and your testing. Don't bother about how to do the division. We'll show you when we are writing the code, how you have to specify computer, remove so-so percentage for my testing, remove so-so percentage for my training. The computer will divide it for you. It will shift 80% for testing, shift 20%, 80% for training and 20% for testing. So when after doing the division, we now take the training part, select the features that we want to use. The features vector now is, since survived is our target, which of these features do we think that is relevant for us to determine if someone survived or not? Name is not important. We are dropping the name. Passenger ID is not important. We are dropping this. So any of the features we think that it is not important, we'll remove it and now work with the ones that are important. So when we have selected those ones that are important, those feature vectors, we now select the algorithm we are going to use. The algorithm is determined by the type of task we want to perform. If we want to perform a binary classification, like this, our task here is binary because we have only 0 and 1. That is our target. That means we can make use of logistic regression. And this logistic regression, we can get the algorithm from this particular library called scikit-learn. We import the algorithm from here. Once we import it, we take this our data and move inside the algorithm. Once we move it inside the algorithm, after training, we'll have our model. So that model that we have developed, we now take the 20% data. That is 20% that is remaining that we did not use for the training without the label. We are not considering the label part, just the feature vectors. We take it and pass it inside the model we trained, and it will make a prediction. That prediction that it made, we now compare it with the correct answer that we're expecting. From that, the correct answer, we now determine, based on the evaluation matrix we are using, it will now be showing if our accuracy is going up or is not going, is going down. This thing is determined when you compare what your model predicted with the actual answer that is being expected at that point. It's like marking someone's script. Here, this white test is the actual answer, and this one is your own answer, is the prediction your model made. When you compare the two, you now know whether your model is training well or is not training well. So we should have this in mind on how we train our model in data analysis. You have your data, you select the features that you want to pass to your algorithm, select the proper algorithm you want to use, pass the data there, you have a model. I think it's as simple as ABC. But there are still some other minor things I'll still explain when we are doing the coding. But just know that this is the basic idea of what happens in teaching computer to understand the pattern. The pattern is not determined by you. We already have algorithms that will help you to determine the pattern. You take the data, pass it here, and you have your model. I think it's already 1 hour because I don't want our class to be wasting more than 1 hour. Okay. Any question? Do we have a question? Chukwuma Samuel Chidimma Eukaria Dika KC Ella Zubike and Co. Any question? Okay. But even if yours is not well clear, when we do the coding, you will understand. But please just have this concept on your mind so you will not be confused when we are writing the code, because everything we are doing in the coding is this thing we're going to follow. This concept